Hello. Hey. This is something I've been doing before every talk. I just kind of like stare at this and calms me down. But I'm Myles. It's very nice to meet all of you. Thank you so much for being here. Before I get started, can we get a quick round of applause for all the organizers who have done such a great job with this event? Yeah, this is my second time at Empire, and I'm just always impressed by the professionalism and how well this event is run and curated. But so, as Jane was saying, I work at a very small disruptive startup. Smaller than last year. But hey, I started working there in the last year, so in my mind it's bigger. But the opinions in this talk are my own. I mean, technically it's the work that I do for IBM, but it's important for you to know that anything that I express, my own opinion, not necessarily that of Big Blue. But so the question, Node.js versions, how do they work? So it turns out that versions are quite a bit like magnets. But no, stick with me. Versions are a lot like magnets in that many people are pretty confused about how the heck they work. But so hashtag real talk, this stuff is complicated, don't be overwhelmed. One of the really cool things about these giant systems is that you don't actually need to know everything to make a meaningful contribution. And that's an important thing in software in general. Don't try to bog your head down with the whole system. You could just learn small parts. And so to talk about Node.js versions, let's get down to an atomic unit and start with a small piece and see how this turns into something bigger. And we'll start with something super fun called semver. So what you can see here is a version number. If you've used software, you've probably seen version numbers. And we have the first digit is the major, the second digit is the minor, and the third digit is the patch. So let's dig into exactly what those mean. So a patch is any change to a project that has no change in behavior and doesn't add any features. Generally, these are bug fixes, or they could be documentation updates or test updates. But generally, any patch change is not going to change the way in which your system works, and it's just going to make your system more stable. So NPM by default usually gives you the ability to automatically take in patch updates. It's really important for security. If you're using Node, you should probably always be running on the latest patch version of LTS, if that's the branch you're using, and we'll get more into that afterwards. What's a minor? A minor is any change that actually introduces a new feature. So the new feature may not actually change any of the behavior of the application, but a new feature is also not necessarily guaranteed to be stable. So generally, new changes come in a minor, and then any fixes to that, to regressions or problems that are introduced by the minor, come in as patches. A major is any big change, anything that breaks the contract between the project that you're using and the project that is using it. So anytime that we update V8, for example, and you need to recompile all your Node modules, that's an example of a major change. It breaks your workflow. The great thing about semantic versioning is it's a way for developers to signal to the people using their projects, hey, this is safe to use, this is maybe safe to use, and plan a sprint to do this. But so Node has a couple different release lines. The current stable release line is v6.2.0. The current active LTS is v4.4.5. And we have some maintenance LTSs, v0.10.4.5 and 0.12.14, which are going to be dead very soon. And I'm happy about that, which is interesting. If you have questions about why 10 and 12 are going away, it's actually because they're both running on OpenSSL v1.0.1, and OpenSSL is dropping support for that release line in October. And so it actually will no longer be safe for us to continue releasing the zero release lines because we don't have guaranteed updates for security of OpenSSL. And if you've been following OpenSSL at all, there's been an absolute ton of CVEs, which are the kind of official way you say there's a security bug. So we're We're playing it safe, and we're going to be moonlighting those at the end of the year. But so you just took a look at that, and you were kind of like, okay, well, we see V4, we see V6, but where the heck are V1 through 3? And what's the deal with 12? So around prior to V1, Node used an alternating release schedule. So every even release was considered stable, and every uneven release was unstable. So many of you may have been used to, like, if you wanted to run Koa, you had to use Node V011 because it had these harmony features enabled that weren't enabled in 0.10. So the idea would be that every even release would only get stable updates for the most part, and anything that was experimental would happen in the uneven release, and then when we were ready to do a new major, we would bump to another even number with the changes from the uneven number. So it turned out that this didn't entirely work, and it took a really, 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 really long time to get to 0.12. And people were getting very restless. People wanted to be eventually getting to V1 so that we could maybe use semantic versioning, but we weren't really getting anywhere. So the project was forked around December of 2014. The fork started by releasing version 1 of a new project known as IOJS. IOJS still shipped with the binary Node, and it was a drop-in replacement for Node, but it wasn't being maintained by Joyent, so it wasn't technically an official release. But a lot of the major players from the community who were large contributors, who weren't feeling like they were able to contribute in the latest release line as it was being maintained by Joyent, found that this was a way to rapidly do all sorts of stuff. And they worked together really quickly, doing lots of releases, following semantic versioning, getting lots of new features in, the biggest one being an updated version of V8, because 0.10 was using a pretty archaic version. So in February of 2015, during Node Summit, around the same time that the Node Foundation was introduced, V0.12 was released by Joyent. 0.12 didn't have that much more than 10. It had an updated version of V8, and it also had some internationalization stuff, but for the most part, it didn't include any of the stuff that was going on in the community in the IOJS fork. And then V1 through 3 all happened following semantic versioning in the IOJS project. And when Node was put into a foundation, the two projects merged together in a release stream that we now know as version 4. Version 4 came with a majorly updated version of V8. We could finally use stuff like let and const and arrow functions and, string interpolation. That was my favorite part. And that was in September of 2015. Around October of 2015, I started working at IBM on Node, primarily working around the LTS release lines. So what you can see here is our LTS long-term support release schedule. So V10 is in maintenance mode, and you can see that it will be in maintenance mode till about October of 2016. V12 is also in maintenance mode, and it's being moonlit sometime between October and December. We have master, which is actively unstable. V4 was the current, it was the head, it was the most active release in April of 2015, and in October of 2015, it was changed into the LTS release line. So the big thing to notice here is that every even version of the release will have an LTS support cycle, and that LTS support cycle is about 30 months. It's 18 months of active LTS, where we're consistently backporting stuff from upstream and keeping things stable and moving things forward. And then we have a maintenance LTS, which is primarily major bugs and major security fixes. So V4, for example, will be moving into maintenance mode next April, and V6 will be moving into active LTS in about October. And we'll get a little bit more into the state of V6 and its stability in a bit. But so we use a couple terms, and what is current? Current is the most active release line. Right now it's V6. Every 6 months, that active release line will go up by 1 digit of a December major release. So in October, V6 will be bumped to V7, and then that will be the latest version of current. What is active LTS? And I had mentioned it before. Active LTS is the time where an LTS release line will be constantly getting updates and things backported to make sure that it's as stable as possible. And maintenance LTS, as I was mentioning, is only security fixes and only, the smaller stuff and only the most important stuff. So like if there's an OpenSSL vulnerability, like there was last month and 2 months ago, we released new versions of V10 and V12. So what about master? So the way that things work is every time someone sends any pull request to Node, that gets landed straight on master. We test those pull requests, and I'll get more into that afterwards, but everything lands on master. Once a week or so, we take all of the Semver minor and Semver patch commits that have happened on master and apply them to the v6 release line and cut a new release. And we'll get more into how that works afterwards. So what happened to stable? Stable was a term that you may have heard when we were doing the v5 releases. We had originally called the kind of like head release line stable, which was a bit of a misnomer. We've had things land, and I'll talk about it afterwards, into master and into stable that introduced regressions. You know, you don't always know when you're introducing regressions or when you're changing behavior, especially it's really easy for something that seems Semver patch to be Semver major. So we ended up changing, when we released v6, the release name from stable to current to not give people the wrong impression. We have no plans to rename things anymore, so I'm sorry if it was confusing, kind of changing names. But we're trying to figure it out as we go, and we're trying to listen to the community and make sure that we're not doing anything that's confusing. So how do we manage all of this? And no, that's not Brian Brennan. But specifically, we use a lot of Git magic. There's a lot of interesting tooling and ways in which we are able to keep all these release lines separate. So we maintain release branches. For each of the release streams, we have a branch that is specifically where we start wherever we're going to do a release. We have 0, 10x, 12x, 4x, 5x, and 6x. Each of these release branches are what we branch off of when we're going to do a new release. So, for example, when we're ready to do a new current release, we'll branch off of v6.x to make a v6 point. In this case, we're on v6.2 right now, so we'd make a v6.2.1 if there's no Semver minors, or v6.3 if there are. We'll add them all in there, and we'll cherry pick those from master, and we'll go through the whole release process. For LTS, it's a little bit different. We maintain staging branches for LTS. So there's a branch called v4.x staging. So the way that something gets backported is unless it's directly applying to the v4.x branch, something has to come into master and needs to land into the latest current release and then live on the current release for at least one release cycle without any regressions before we'll even consider backporting it to LTS. At that point, once it's ready to be backported, we backport it to the staging branch. And by keeping everything on the staging branch, we keep a clean version of the v4.x branch. So if we have any weird security problems that we need to do, we can branch off of v4.x and apply the security updates and not have to do any like weird hackery. And as I said, all the changes must live a week. So let's do a little demo. So this is kind of like the process that I do when I'm backporting things. So I'll go to pull requests here, and we'll take our labels, and we'll look for the LTS watch 4.x label. We'll look at all the closed all the closed PRs. So the big thing that we're seeing here is that any commit that we think might need to be backported, we're applying this LTS v4.x label. So we have this commit that's actually been sitting there for a while. We're planning a minor release to LTS. We don't do that very often. But once in a while, the CTC and the LTS working group will vote on specific changes that are not likely to have regressions to fix the experience in LTS. So in this one, for example, debugging REPL is really hard to do, and there was a fix on v5 that made this easier. So we have this whole thread where people discuss, like, should we do this, should we not do it, what's the Semver? And eventually it was decided we should land it. It landed in this commit, and you can see the discussion about LTS, and the working group had a meeting and decided that we would land it. So we have this commit right here. So cool little fact about GitHub that you may or may not know. I can't do it right now, but here we go. If you add .patch to the end of any GitHub commit, you are actually going to get a patch commit, which is like a Git mail message, which is an older way in which Git was used. But so I have a little tool. I can go here. I can copy the commit. I can use this little alias I have, git patch it, and post it in. And oh, it didn't apply. Okay, so we're going to abort that, and then we're just going to say please. And now it worked. So just so we can see what's going on there, if I grep patch, only garbage. Oh, I forgot to write grep. So we can see this really nasty set expression and stuff, but essentially what we're doing is we're curling the patch, we're piping it into get AM with whitespace fix, is what patch it does. Then I have patch it please, which just uses AM with a three-way merge. So generally we try to apply the patches directly onto the head whenever we land patches, but sometimes that doesn't work, so we use the three-way merge strategy. So that's just kind of like the alias I made. If it doesn't work, I call please, and sometimes that works. But, so this is the fun part. So we just updated Node. And so the next step would be to go back to this. We'll remove the watched label, and we will say land on to let us know that that is ready to land in our next 4.x release. So back to the talk. When we're ready for an LTS release, we branch off of v4.x, and then we cherry pick commits from v4.x staging directly onto the branch that we've made. We do this using a couple different tools. So, like how do we know what to cherry pick? This is kind of a hard thing. You can use git diff, but git diff usually only works via SHA. So if you have two different release lines with slightly different trees, git diff isn't going to let you know, hey, this commit exists on master, but doesn't exist on v4. So we use GitHub labels to label the things that we need to do, such as semver major, semver minor, LTS watch, and don't land. With those labels, we can know, hey, what's the semveriness of this patch? And then we can also know whether or not it's a patch that we want to see. We then have a number of tools. Our release tools, such as branch diff, changelog maker, and some release scripts. So these are tools that were written by Rod Vag. So what we can do here is we could take a look, and we can run branch diff, and we could say, hey, what's the difference right now between v4.x and v4.x staging? And it's going to go through, it's going to look at the two branches, it's going to show us, hey, these are all the commits that exist there without it. So I could, for example, branch off of 4.x, and I could do branch diff. I can say that I want the format to equal SHA. I can tell it that I want it to be reversed. I can then pipe that into xargs get cherry pick. And like magic, we've built a release branch. And that's like a quick way that we can use some tooling. So if we wanted to, for example, see what commits are not on staging, we could do a branch diff of v4x staging against master, and then add a couple flags to say, hey, ignore the don't land flags, ignore the semver minor flags, and it will actually build us a whole list of all the commits that haven't landed or been labeled. And then we can audit that and know that, hey, there's no floating patches that haven't been backported that we want backported. These tools are really great, and then we have some other release tools that we use as well. If you dig into Rod's code, he built some really awesome stream-based utilities for interacting with the GitHub API, and I really suggest taking a peek at that. So we talked about breaking changes. Like, what exactly is a breaking change? And primarily a breaking change, as I mentioned before, is anything that changes behavior. So anything that changes the expected contract between the library and the user. So how do we avoid breaking changes? One way we do it is with CI. We have a couple thousand unit tests that we run every time a change is going to land that touches code and not documentation. And we also do something called smoke testing. So I worked on a utility called Canary in the Goldmine for the last couple months, and what it's able to do is it's able to grab any particular node module online. It will grab its tarball from GitHub, it will npm install, and then it will run its test suite, and then it will tell us if it works. So for example, we could here go like sitgim, and this is, I made a little module called oh my god I passed that always passes. And it passed. And then I've got a module called oh my god I fail, which always fails. Oh no. It's just really easy. Those are used for tests. But what we have is we have a lookup table with the 60 most actively used modules in the ecosystem. And every time we have a very controversial commit, like something that touches streams or something that touches the module API, or anytime we're about to do a release, we have a CI job that runs the unit test suite of all of these 60 modules against the head of our release branch and can tell us, hey, are we breaking the ecosystem? And so this find some really interesting things. So on the week of February 4th, we actually found out that both Jade and BodyParser were broken on master, which was odd. Jade ended up being really simple. Jade had to change their name to Pug. So our algorithm for actually resolving the tarball broke, so I sent them a pull request to update their package JSON, and then everything worked again. BodyParser was a little weird. For any of you who don't know BodyParser is a module used in Express for parsing the body of HTTP requests. So you can imagine this is a module that if it broke, everyone's going to have a really, really, really bad day. So a commit came in that touched query string .parse. And what it did is it used string.prototype.split's limit. It's an argument that you can give to prototype.split instead of us doing it manually. Because at first, we were parsing the array, and then we were just handing back a subset of that array. That creates garbage, that does extra calculations, and people were like, oh, well, it would be way faster if we just use split. And that was great, and things were like 300% faster. The change was very minimal, as you can see here. But it broke everything. Because what ended up happening was there's this crazy thing called infinity. So the way that we were doing it before, infinity would actually be a no-op, and we wouldn't shorten the array. But string.split, its argument for max length is expecting an integer. And in JavaScript weirdness, when infinity is cast as an integer, it's 0. Which actually, I mean, realistically, 0 is way closer to infinity than any other number. But that doesn't really work when you want an array that has information in it. So for example, prior to the change, had you called parse on infinity, the length would be 1. After the change, the length would be 0. That's no good. So what ended up happening was we actually didn't have a unit test in Node to test infinity as an argument to parse. So we didn't catch this like one weird edge case. BodyParser, Doug Wilson wrote 1 million tests, including a test for infinity, and that test broke. So I was able to go in and quickly write a unit test that didn't involve BodyParser, and then it was like a one-line change to check if people had used infinity, and if so, not to pass it. And everything just worked, and smoke testing saved the day. But so this is interesting, because while the change was on master, it had not made its way into a release yet. And as such, we were able to land a fix before it actually ended up in a release and broke anyone. So none of you ever actually experienced what could have been, if this had happened like 6 or 7 months ago, a pretty major ecosystem breakage on a patch change, which would have been really bad. So Sitgim has found all sorts of crazy weirdness. I've kept a diary, and feel free to let me know. I can tell you the repo of where that lives if you want to just see all the weird ways that things in the NPM ecosystem break. So this leads us to close to the end, which is the question of which version of Node should you use? And mostly I'm talking about in production. And I push generally to use anything on v4, and generally the latest release on v4. We work extremely hard to make sure that even the December patch updates to v4, which happens very rarely, are not going to have any regressions. We make sure of that to make sure that you can always update to the latest version for security reasons. So we had to release v4.3 because of an OpenSSL bug. We want to make sure people are running on that. v4.4 had some other Semver minor stuff that was added also for security and robustness. We want to have a contract with you where you can feel completely comfortable always running off of the bleeding edge version of 4.x and never really have to worry about regressions. And I told you the longest support cycle closest to the LTS lines, and it's not likely to break. Do you have to? No, you can really do whatever you want. I'm not going to tell you what to do. V6 comes with the latest version of V8, which comes with all the new ES 2016 goodies, and there's some valid reasons why you may want to use that. I'd maybe edge you to wait until October to do it, or closer to October. If you've been following, there were some interesting regressions in require and in real path implementations that could leave you with some pretty unexpected and weird errors. We're still fixing those. By October, we do have a promise to the community, though, to have V6 in a very stable LTS-like state. So if you're going to use V6, the only thing I can say is be prepared for breakages if you're an early adopter. So that's it for now. Thank you very much for listening to me. If you have any questions, just grab me.
All right, Myles Borins, ladies and gentlemen. Come on, yeah, come on over. Join me on the couch. I think actually I jotted down a question and you answered it right there at the end. So is LTS the safe version, right?
Yeah.
Yeah, because I think like many developers, I myself also see new version of Node. Let's go play with it, and you download it immediately, and then off it goes. But I mean, do you have a favorite sort of like version manager? Do you use like NVM or like N?
I use NVM.
Yeah.
And there's actually an application in right now to have NVM join the foundation. There's a bit of a discussion about whether or not that's the right thing to do, because it's similar to how Express asked to join the foundation. We don't want to look like we're saying any one project is better than any other.
Right.
But for myself, I actually think that a version manager built into core itself would be very useful.
Right. If you're going to sort of maintain these like two sort of versions, right? You want people to be able to play with the latest thing, try their stuff out, but also have like sort of a safer version to sort of run in production, right?
Yeah. And it's worth saying, like, I don't want to scare people off of using V6. The way that we'll find the bugs and make it more stable is by people using it. I just want to make sure that people who have critical production apps don't risk their jobs or put themselves in a bad situation.
Definitely. So, for those of us at home on Heroku, go bleeding edge, try it out, go crazy. If you're running a billion-dollar company, maybe, practice a little caution.
I do know that certain billion-dollar companies may be using V6 in production.
Well, you know what? Some of us like to live on the edge.
Yeah.
That's right. Fantastic. Semver was something I didn't really understand at first, and then sort of as somebody sort of explained like what each of the numbers work, I was like, yeah, that makes a lot of sense. I've really been impressed by like projects like Semantic Release, and there's like, are there any other sort of like tools or like sort of resources that you like love around like semantic versioning, or do you find that most everybody you talk to sort of like already gets semantic versioning?
So, I mean, there's no tool that's going to solve semantic versioning for you. Greenkeeper.io and Canary in the Goldmine are...
We got some Greenkeeper fans in the house tonight.
Those are good tools that you can use to help make sure that you're not breaking your dependence or your dependencies aren't breaking you. And I've actually been talking with some of the people involved there to figure out ways to make this better for the ecosystem. But I mean, it's kind of on you to a certain extent to make sure that you have processes in place that allow you to have a clean contract.
Yeah, right on. Thank you so much. Ladies and gentlemen, Myles Borins.